Hello, everyone, and thank you for joining us for this new webinar organized by GSOA, focusing today on the future of Satcom mobility. So my name is Jean-Baptiste Tepo. I am a principal at Novaspace, where I am coordinating the activities of the company related to satellite communications, and I have the great pleasure of serving as the moderator of today's discussions. Without further ado, please let me introduce our panelists today. So starting with Per Welberg, Executive Vice President, Business Development and founder of Ovzon. We also have David Fotheringham, Senior Director, Product Management at Meta. We have Ofer Gal with us, so RF and Antenna Product Manager at Gilat. And we have Khalid Al-Naqbi, Vice President, Product and Engineering at Space42. We only have 1 hour and we have a lot of topic to cover today, so let's dive right in with a few words of context on the mobility market coming from Novaspace's latest research report. And before looking specifically at mobility markets, let's take a step back and look at the broader satellite connectivity and video market. So a lot has happened over recent year. The entry in service of NGSO constellations in general and of Starlink in particular has massively disrupted our entire industry, starting first with the consumer broadband market and progressively expanding to most connectivity verticals. Satellite customer expectations have been largely remodeled. Customers have progressively abandoned historical satellite requirements such as committed information rates and have massively adopted new standards such as flat panel antennas, for example. Competition has intensified drastically and the entire value chain adapted to the new state of the market by either becoming NGSO distributors or by actively organizing the resistance and making plans for their own competing NGSO constellations. We are now on the verge of a new area. Now that the dust starts to settle, it's time to reimagine satellite connectivity. So we have 2 active LEO broadband constellations at the moment, and we have at least 3 to 4 other constellations with a decent chance of materialization in the near future. So competition will continue to intensify. However, satellite services will change considerably in the future. We will see more and more hybrid networks combining GEO with MEO and LEO capabilities. We will see a gradual transformation of traditional satellite services with the objective of ensuring a seamless experience at home, at sea, or in the air. And we will see the emergence of new services such as direct-to-device and IoT. As you can see on this slide, the massive growth of the satellite supply that we witnessed over the past few years is not expected to suddenly stop. Total supply is expected to be multiplied by 20 between 2024 and 2030, and 99.7% of this supply growth will come from NGSO systems, which will be fueled by the entry in service of mega constellations such as Amazon Kuiper and the V3 generation of Starlink satellite systems. Thankfully, demand will also grow considerably within the next 10 years, albeit at a slower pace than supply, driven both by the installed base of active Satcom terminals, which is expected to be multiplied by 3, and by the individual data consumption of these terminals, which is expected to be multiplied by 2.5 to 12, depending on the verticals within the next decade. All in all, this results in a total demand in volumes for satellite communications growing at a CAGR of 27% within the next 10 years. So let's look now specifically at the mobility market, which is set to be the fastest growing VSAT, one of the fastest growing VSAT segments. While aero and maritime markets are already well established, terrestrial VSATs remain in its early development stage. Still, some subsegments, such as RV connectivity, have gained a lot of momentum over recent years, and trial deployments on train, buses, and emergency vehicles are multiplying. Even agricultural machinery is beginning to tap satellite broadband, underscoring the growing appetite for true comms on the move. The aero market will be the biggest contributor to the growth of the mobility market over the next few years, driven by the lower cost of NGSO and VHTS capacity, a rising onboard Wi-Fi adoption, and the development of new data-intensive services, which altogether will boost the individual consumption per aircraft. The maritime market will experience a more modest growth, but will still increase by a CAGR of 18% annually, driven by the aggressive pricing strategy of NGSO constellations, which open markets that were previously unaddressable by satellite, such as, for example, the small leisure vessel market, and by the surging capacity demand from crew and passengers alike. As you can see on the chart on the right, however, NGSO system will capture 90% of the growth between 2025 and 2034, thanks to ample supply available over oceanic routes and truly global coverage brought by NGSO constellations. But I don't want to overtalk. Let's now focus on the panel discussions. We have a very interesting panel today, as your respective companies operate both at different levels of the value chain, but also on different vertical markets, which will bring an interesting perspective to the debate. So question to all of you first. What are the main changes that you have observed on mobility market over the past year? Per, do you want to start the answers?
Sure. And again, this is from our perspective, focusing very much on the defense sector and civil defense. So instead of maybe kind of competition at pure throughput, the kind of assured connectivity, I mean, to the resiliency part of it has proven to be extremely important. I mean, as we've seen, providing services in the most contested environments where you don't have any positioning data or where somebody is actively targeting space, to have a system that works, top trumps the rest. We have great, throughput as well and mobility, but resilience is super important. That's what we've seen.
Okay. David, do you want to complement that?
Yeah, for sure. So defense is one of our largest markets that we serve, and absolutely the things were just said are spot on. The broad use of GNSS denial tactics in the defense space now is changing the expectation. It's bleeding over into the commercial space as well for like commercial shipping lanes that go near these regions. So it's actually affecting both in the defense and commercial spaces for expectations around GNSS denied solution sets and capabilities. These are things that are now becoming mandatory, and we're making them core to all of the products we're developing right now, adding that capability set to our user terminals. In addition to that, multi-orbit, multi-network, being able to roam across different solution provider spaces is critical. You can't rely on any one solution provider to be your only solution provider. You have to have a multi-provider or multi-network strategy. And so again, you'll see all of our products over the last couple of years and going forward are starting to incorporate more and more technology to enable that.
Thank you. Ofer, what are your views on the past year?
Well, we are seeing the market growth, as you mentioned. As David mentioned, we are also seeing a multi-orbit requirement in the market, GEO plus MEO plus LEO. And we are also seeing a dramatic surge, at least here in Gilat, we are seeing a dramatic surge in aero demand, in defense demand from practically all around the world.
And finally, Khalid, do you want to add something on that?
Yes, absolutely. We have witnessed many changes in the past 5 years. Employment techniques, people prefer to work remotely, explore the world, many geopolitical, cybersecurity challenges. And I see that a lot more nations are keen on having space programs that provide mobility or international services that make the aero, maritime, and even land applications more resilient. We're definitely living in an exciting period.
Definitely. Thanks a lot for that. So second question, still on the broad state of the mobility market. So LEO constellations, as we have seen just before, have disrupted quite significantly mobility market over the past few years. What did it change to your respective business models and overall economics? Khalid, do you want to start on this one?
Absolutely. So being vertically integrated has become quite important recently, having launch capability that will be able to pump as many satellites as necessary to complete a satellite fleet, having the necessary spectrum to complement that network, and obtaining the technology on ground to provide services, whether aided by artificial intelligence or otherwise, is definitely transforming the entire ecosystem of space and mobility.
Great, thank you. Ofer, you want to go next?
Well, the introduction of the non-GEO and the LEO has solved the delay issue of it used to plague Geo systems, and it has enabled us to support our customers with a quality of service that truly resembles fast terrestrial networks and the abundance of bandwidth, and we expect this abundance to even continue and expand into Ka band with the introduction of the new Telesat and other Ka constellations, will enable us to provide truly cost-effective, global, terrestrial-like services. And indeed, we are seeing satellite connectivity making roads into applications that were not there. And the introduction of Starlink into the market also added a lot of awareness all over the world to the satellite solution, which also increases the entire ecosystem and making many things that used to be expensive much more cost effective, whether it is chipsets, whether it is management, etc. So I think we are already in the area of great expansion in satellite communications, and we are very optimistic.
Interesting. David, do you share the same perspective on this market than Ofer?
Yeah, so, pretty much. The big things I'm seeing in terms of the changes that are affecting us are the price expectations. So as we see lower cost solutions come onto the market, and largely vertically integrated lower cost solutions, when I look at the legacy markets, there's still a higher willingness to pay as long as they're getting a better value for the money they're paying. And so it's going to be more feature dense, more complex systems, more capable systems. The features I talked about earlier in terms of GNSS denied. So having more of that capability density in the terminal and more resilient terminals, and then communication strategy. So the orchestration of multiple networks. These more complete solutions are what people are going to pay the more premium prices for going into the future. It is a LEO first world going forward, though GEO is out there and people will still use it. I've already seen a rapid, we are an SSP also, so seeing GEO utilization versus our LEO utilization for our services we sell, it's a massive shift towards LEO in terms of total packets moved, but also just user time spent on network, and it's broadly shifted over to LEO.
Thank you. Per, any final word on these questions?
Yeah, I think what's positive, it's raised expectations, which I think is good for the business. But I think looking at how it affected our kind of business model and approach, it has confirmed it, because every system has its advantages and disadvantages. And when we started with a very kind of niche solution, providing highest mobility performance and resiliency. And what we see, so we were orbit agnostics, when we went in, we had just those, customer requirements, and that kind of led to the choices. For sure, we didn't have a cornucopia of financing either. Nobody has, almost. And so that led to our solution, and a system that again works in areas where you have an actual conflict. And so I think it has only strengthened that, which is positive, we think.
Yeah, interesting. Thank you all for that. So now, if we look at the current state of the market, where do you see the biggest gaps today between the expectation of the users and the actual capabilities of current mobility solutions? What are the bottlenecks today? Maybe we can start with you, David.
Sure. So the biggest one for us, and you'll see it again in our going forward products, we built our legacy, our current products and before, to be compatible with legacy GEO networks. And as the emphasis on GEO declines, we can take advantage of that by shifting the product size and weight smaller. So we built large user terminals to accommodate the older or legacy networks or the GEO networks. You need more performance to close that link. As the emphasis shifts, and also the benefit of having more VHTS, HTS satellites up there, we can close links with smaller terminals. Both of those are pushing us in the direction of smaller user terminals, which then enable more attachment to more diverse platforms, smaller platforms like the USVs, and the growing military markets around autonomous vehicles is a huge one.
Thank you. Khalid, you want to go next on this one?
Yes, of course. So we at Space 42, from where I sit, with the launch of our T4 this year and launching the services on it, we launched a large family of products on broadband on T4. And be it serving the governmental clients of ours or the commercial ones, we're big on both fronts. And the gaps are basically, this connectivity is no longer an option on both fronts. All those products, we provide the maritime, the aero, the vehicular, the handheld, and the voice products like our Thuraya One, and secure satellite phones. Basically, the requirement on both fronts is connected everywhere at all times.
Great, thank you. Per, any further word on that?
Yeah, and maybe it sounds like a repetition, but again, I mean, what we saw when we started was this kind of combination of having very high mobility, meaning ultra small terminals connected to high throughput, not just receive. In our sector, they want to transmit often more than they want to receive, which poses a challenge when you design a system. And finally, the resiliency to have those in combination. And it comes with a price. You can buy a consumer, and again, as we all agree, Starlink is beautiful and great, but in certain mission critical application, it's not useful. And yeah, so we saw a gap, and that is what we are pursuing.
Thank you. Ofer?
I think that in terms of size, weight, power, throughput, the new satellite terminals in the LEO era are improving greatly. As David said, we can now close the link with much smaller antennas. With the introduction of electronically steered antennas, we have no moving parts, so the resilience, mechanical resilience, and the zero maintenance are much improved. Where we still see a gap is in the customer expectation of having a solution that resembles, let's say, a cellular service, meaning zero maintenance, easy to operate, make it as simple as operating in cellular, and it should, of course, work with no need for any training or anything of that sort. And we still have to simplify and make the experience of the user truly, let's call it cellular-like, or something that is very simple to install, to operate, and to maintain.
Perfect. That's a perfect segue to my next topic, which is more on the technology evolution now, so which is in the end the real enabler of seamless connectivity. Starting first with hybrid GEO-LEO connectivity, which has been mentioned, I think, before by David, and which sits at the core of many operator strategies today. So what technological breakthroughs are the most critical to achieving true multi-orbit mobility? Ofer, since you're still on my screen, do you want to start on this one?
I would say that it's not really a technological breakthrough. There are GEO-LEO platforms today. David and Kaimeta are one example. Gilat with Sidewinder is another example, and there are others also in the market. So it's not really a technological breakthrough. It is working today. We have hundreds of airplanes flying today with our platforms, with GEO and LEO working simultaneously, no issue at all. And the seamless transition is also a byproduct of the new chipsets and the electronic steering of antennas. So it's not that much of I would say, technological breakthrough. These things have been solved, Gilat and others. The question is, which market segment are you trying to approach? For example, if you're trying to give service, let's say, to a business airplane, you need a very small antenna, and you don't need to serve that many people in a biz air solution, so you can use only LEO. If you are serving a commercial aircraft, for example, and you want to give internet connectivity to 200 people simultaneously, you will want a very large antenna with GEO and LEO dual operation. Or if you want a resilient solution, let's say for a defense application, you need GEO and LEO. So the technical breakthroughs are, I would say, behind us, and every market segment will adopt the right solution, because in some cases, customers will be willing to pay the price of the platform in cost, in weight, in power consumption, and in some cases, they would prefer to go with LEO only, with a very small micro type of platform.
Thank you. David, do you share the same feeling as Ofer?
Yeah, so multi-orbit, so we consider that box checked in terms of multi-orbit. We've got 2 products in the market, 1 more coming. What we made news on earlier this year is actually what we think is coming next as a part of this convergence happening, to ensure multiple networks concurrently with fast switching between them, or interoperability, or even bonding of them is what I'm seeing the expectation growing into. So the new, more premium products are going to pull together multiple networks. So that business airline use case mentioned, that's a perfect example. They don't have the real estate, but they may still want network diversity. They may still operate in different regions that have different service providers available, and you want that ability to roam across these networks. So an antenna that works across KU and Ka-band. So earlier this year, we announced that we had the technology breakthrough on a fully integrated single antenna that had concurrent KU and Ka operation. That's exactly the direction we think the world wants the user terminals to go, so that you have not just single band multi-network, but multi-band multi-network and concurrent whenever possible.
Thank you. Per, what are your thoughts on this?
Yeah, and again, maybe it sounds a little bit provocative here, but at the end, I mean, you have the satellites are tools, right? They're up there, and you need to have a user need, and sometimes I feel, and maybe it's unfair, that so it's really the need that you drive. Yes, we want to have multi-orbit for this or this reason. Sometimes I feel that you have a legacy assets, and something now has been added, and you're finding applications for it, and again, it may be a little bit unfair. I think it's good. Again, I think, as I said earlier, every kind of orbital plane have its different advantages, but also disadvantages. The problem, because I founded a company before this that made terminals, Swedish satellite system, a very long time ago. Anyhow, but it's really the terminal that you see, that's your interface towards the service. And that becomes setting down in this chain of different things, setting the limits to the weakest link, really. And it might be a super good terminal, or it might be some kind of, not a Frankenstein monster, but I think sometimes it's a challenge to do everything. And I think Meta and David, you have done great products in that, but it's a challenge. Yeah, so that's my comment.
Agreed, it's very difficult.
Thank you. Khalid, any words on that?
Yeah, without sounding redundant, speaking historically about GEO satellites, they were serving a sovereign function where they provide connectivity to governments and militaries for that particular nation. But part of the definition of a new space, all those LEO constellations where they provide reach and reduced latency, GEO will always be there, and I wouldn't personally call them legacy. They continue to evolve. The new eSpace touching GEO is smaller, a satellite, lower launch cost, and they still possess the same functions of high throughput, beamforming, targeted markets, and so on. So I think they will work together nicely. And on the product side, a lot of the products, as my colleagues mentioned, are multi-orbital, where the new offering can talk to LEO, can talk to GEO, no problem. So I think they will both serve different purposes. On our T4, for example, we do provide mobility solutions, and we provide IoT solutions, and it's a GEO satellite sitting at 38,000 kilometers.
Right. Perfect. All right. So now let's explore how this technology translates into real-world applications. And just before that, I just need to remind maybe the audience, for those who joined us a bit later, to post their questions via the Q&A button and not through the chat button. So there is a specific Q&A button at the bottom of the screen that you can use for that. So looking now at the application, so which mobility segments, we have discussed maritime, aviation, land, is driving the most innovation today, and which do you expect to grow faster over the next few years? So Khalid, do you want to start on this one?
Surely. I think the maritime segment with the vessels obtaining so much property, I think they will be satisfied with current technology. Current technology is available, but I believe the airborne segment is going to see a transformative shift where those ESA solutions, which a lot of them exist today, some of them probably are in development, will actually solve a lot of gaps.
Thank you. Per, do you want to go next?
Yeah, and just to comment, I wasn't clear, and Khalid, we use GEO as well, so I didn't mean all satellites are legacy. So I think it's beautiful. GEO is super good. All right, so yeah, I mean, again, from our perspective, application use cases that we see, trying to make the system as, enabling as high mobility and resilience and performance as possible is, for example, unmanned platforms. And you have many smaller unmanned platforms that might have the range and endurance, but they are limited by their terrestrial comms. So when they pass a building or a house or a mountain, you will lose communication with it. And I brought with me, I don't know, it's not possible to see this. So it's a beautiful terminal. It's very small, at least. What we're doing now, and where you can then equip, smaller unmanned platforms. So that's a big driver within then defense, but also civil defense, I would say. Just an example.
Thank you. Ofer, what are your views on this?
As Per said, I think that in the defense sector, we will see a lot of innovation. Typically, the defense sector naturally leads, and especially in unmanned platforms, but not only. And I think that on the aero platforms, as Khalid said, ships, especially the large ships, have a very good solutions also over Geo. But in the aero industry, I believe that we will see airlines going through the same transformation that, let's say, coffee shops or hotels past a decade ago, where the demand of the customer to be always connected becomes like something obvious. And today, every coffee shop, every hotel, every airport provides connectivity to its customers, and these customers will expect it to continue to the air. And the technology and the cost effectiveness is now here. So I believe that, the aero industry will be the next big thing.
Thank you. David, any final word on this question?
Yeah, I see a natural progression. So as Ofer was just saying, the military starts and they take everything and anything and test it early. It then moves into the what I call generally people mover markets, starting with aero into the maritime, over to now to rail. Rail wasn't historically very receptive to satellite, given the frequent outages of the land blockages. But with the large pipes, anything that has a lot of people on it now can fill in those gaps in the terrestrial network, both maritime and rail. And so we're seeing now this movement. Every one of those markets has very different demanding requirement sets and certification processes. And so there's a definitely an expense to entering these markets, and each one is unique, and each one has a cost and a time associated with it. So that's driving a lot of the trade space that I am negotiating on a daily basis for these things. Power efficiency is going up. Everyone wants to use less fuel, wants to be more energy efficient in the design. So that's an important aspect. The height of the antennas, there's with aero and with rail and high-speed rail, and even in military, anything that creates a protrusion creates an obstacle for somebody in some way. So there's a lot of pressure to really skinny down the terminal in terms of its Z height. So that's another area where we're having to spend a lot of time on how we redesign and lay out the terminal and get the capabilities all in there, but our envelopes are shrinking.
Thank you. If we now look at the expectation from the users, they have evolved quite a lot over the past few years. What are your customers prioritizing at the moment? Is it throughput, latency, cost, resilience, or a mix of all these elements? You can start with you, Per. What is it on the defense market, for example?
And it's all of the above, as you say, but when it depends again on the customer segment, certainly for defense, and that's what we're trying. There is no idea to buy a system if it doesn't work during an actual conflict, if it just works in peacetime or welfare or controlled exercises. It needs to work during conflict, and it comes with a price. So for sure, they want a lot of throughput, they want as small terminals as possible, and they want resiliency. And those, if you go in one direction, you will have to suffer in the others. But we try to make a good compromise, we think. But certainly resiliency in the defense now is understood more.
Thank you. Khalid, you want to go next on this one?
So I think cost and resilience have always been there, and we've all sat in those negotiation rooms where we have to reduce cost and increase resilience at all times. But I think throughput and latency are quite important. Latency brought us down to LEO, and that to feed both worlds, the commercial and the government. Those small systems like unmanned drones, missiles are becoming more advanced and more expensive, where targeting is important, where making sure of hitting the target is of extreme importance. The throughput allows for information received. Applications like manned-unmanned teaming is quite important, and it's changing the war zones and many other applications. So I would say throughput and latency are probably prioritized over the rest.
Thank you. David, any more than that?
Yes. I think I'll pass for now. I think I've been a little bit redundant. I feel I'm just going to keep saying the same thing for the moment.
No problem at all. Of course. And Ofer, do you have anything to add on this one?
No, I think Khalid said it very, very accurately.
Perfectly. Well, we have a total agreement in our panels. That's good. Let's move to the next question. So these days, it's quite hard to moderate any satellite panel without mentioning D2D at least once, considering the considerable investment that went into this application. But do you see any potential of D2D solutions, direct-to-device connectivity in mobility contexts? Maybe we can start with you, Khalid, if you could tell us a bit more about your recently announced Equatis initiative that you led with Viasat, and whether you intend to target mobility markets or not.
I personally cannot wait for Equatis to go live, and we're targeting 2028 with our partner Viasat on that. Equatis, I believe, is going to change our personal experience holding those new unmodified chipsets and new mobile phones in our hands without the need to maybe buy roaming wherever you go in each different country. Having those towers in the sky is going to be a game changer. And I bet all of us have seen some sort of race towards that direct-to-device world. If we take that to an maritime application, it is all well and great. It maybe will eliminate the need for welfare, where traditional Satcom and LEO constellation will provide the heavy lifting of data throughput, but the people on board that boat will be connected at all times for text and voice, probably even further at later stages. When talking about airborne applications, I think similar approach would apply as well.
Thank you. David, Per, and Ofer, do you have any further comments on the D2D thing?
Yeah, so D2D, I'm not looking at it in the sense of to my cell phone. I think that was already spoken about. But we started integrating cellular into our terminals about 5 years ago. And with the cellular in there, you have that obviously that multi-network terrestrial satellite. Now with GEO only, there was this destructive bonding piece that happened. But when you have this D2D piece in there, now you have this out-of-band thing. So today I'd have to put an Iridium modem in also, or a Globalstar modem in to get that other piece of that out-of-band, narrow-band communication link in there. If I get that as part of the cellular modem I've just put in, the value is great. So I have this out-of-band link, I can do orchestration, I can do security management through it. It adds this wonderful layer of both resilience and there's reasons for, as I was just mentioning, you want to have a multi-path capability so that whether you're having an outage or whether you're wanting to do something for security reasons out of the primary network, you can use these alternative carriers and things. If you do it concurrently, it's even better. So I really like the idea of that multiple modem concurrent capability across multiple networks. It creates really powerful solutions.
Thank you. Per, any additional words on this one?
No, I think no. It's when I direct to device, I see it directly to the telephone, as you say, without any. And of course, LEO is better than because it's closer, but it's still a challenge as the base station is very far away. But the thing that I couldn't show you here is the size is just 11 centimeters. So it's pretty. But I think for us, more than kind of sending Morse code and little text messages, I think. For us, we want to send broadband, information then, multi-megabit in order to be effective. So that's, what we have designed here, which is even larger challenge having a GEO then.
Thank you. Ofer, anything to add on this one?
I think, as David said, the direct-to-device is great when it comes to resilience, multipath, the ability to work simultaneously on multiple networks. I think it's great also for emergency and things like that. Because of the limitation of using a very small device, there is an inherent technical issue with the speeds that this technology can support. It will not be a solution for every market segment. It can serve for certain things, but for example, for broadband, I don't see this technology becoming mainstream simply because of the speeds and the efficiency that do not exist in the direct-to-device. It's an excellent solution for, let's say, voice, text, WhatsApp kind of applications, not necessarily for supporting broadband. We are also waiting impatiently for this technology because it will bring certain chipsets into the market that will enable us in even more cost effectively than today to support certain things that today are not require us to use either software or more expensive hardware.
Thank you. And somehow a related question as well. So a lot of the industry's future depends on integration, both between orbits and with terrestrial network. And these past few years, so we have seen the emergence of new satellite architectures, which are notably 5G based. I'm thinking notably of the IRIS² project in Europe, which should be natively 5G compatible. So is seamless handover between satellite and terrestrial 5G networks close to becoming reality, or is it still a few years away? Ofer, if you want to start on this one.
I think we are still a few years away. It's the right direction, and we are progressing all the time. And we in Gilat are also involved in some projects that are in this direction. But it will take a few years, and it's not that easy and straightforward to implement.
Thank you. David, you want to go next on this one?
Yeah, so there are ways you can seamlessly integrate satellite and terrestrial today. You just have to be very careful about your latency matching, as I mentioned a second ago. But you'll have to use some sort of a wrapper, so a single endpoint in the cloud with multiple WANs going into that endpoint to maintain that session continuity across the multiple links. So you can do that today. Our products today offer a feature that can do that. But what people really want is that 3GPP compliant end-to-end architecture with my dream is a common chipset that roams across all of them. So I'm not having to support 2, 3, 4, 5 modems in the terminal anymore. It's one modem or two modems and you're able to use those dynamically to switch through all these networks, terrestrial and satellite. So yeah, that's still years away, but I am fully cognizant of what's happening in 3GPP and a big a fan of what's happening there. I'm thinking about this is what's going to happen in the 6G future. This is where these things finally converge.
Thank you. Per, do you share the same view?
Yeah, I do, and as a lot of people here have said that, I mean, the availability of COTS components, I mean, because there are very expensive parts today, you know, in the terminals to have access to that. What we've seen is, so we have a couple of projects here, and it's, you know, the kind of mod code and waveforms aren't really optimized, at least in the until 6G then, but for going out in space, because we use what is, you know, optimal for what we do and satellite communication. But as you said, I think, David, I think with 6G, then you know, we will see a kind of convergence of terrestrial and space, which is inevitable. And I think it's super good.
Thank you. Khalid?
I think it may be sooner than we think. We can already send SOS messages on satellite using our handheld devices today. That's when talking about direct to device. I think the delay may be mostly about getting agreements in place with MNOs, again, into the direct to device world. Those agreements may be jeopardized by geopolitical relationships, forming alliances in space. But I think the technology is capable, and all parts of the puzzle are falling together nicely. The standards, the technology, and the agreements. We recently signed an MOU with EAND, that is Etisalat, and Etisalat is operational in many countries as an MNO, and they're going to be our first partner utilizing Equitas space towers.
Thank you. All right, let's move now to business strategy. So we've seen over the past few years that vertically integrated players have taken a much bigger role, and we have seen the rise of fully vertically integrated players, from the manufacturing of the satellite to the service provision. What is your views on this new landscape, and do you expect vertically integrated players or open architecture ecosystems to dominate the Satcom mobility market in the future? Per, do you want to start on this one?
Yeah, and this is just our approach. I mean, so we are vertically integrated. I mean, we do make the terminals, we make the modems in the terminals. We didn't make the actual satellite, but we made the payload and the onboard processor, which is unique. So I think for our application, we needed to have control over the whole chain in order to go down in size and do all these things we talked about earlier. But I think for you know, for more broader applications, I think it's very good to have, you know, open standards and that you can have, as we see in the rest of the world. But as you say, I mean, Starlink extremely, you know, they do everything, and so it's a good question. So we took the kind of proprietary or a vertically integrated route ourselves.
Thank you. Ofer, you want to go next?
I think there will be vertically integrated players and there will be open architecture players. As Per said, Starlink is totally vertically, and OneWeb, for example, is adopting a more open architecture. I think that in the largest scale solution, say consumer or enterprise, we will see a fully integrated players taking over, being the most dominant by far. And I think that in, let's say, the high-end markets, the defense, the aero, etc., we will see interoperability, and we will see more niche players that have special, dedicated, optimized platforms. And these players are not necessarily vertically integrated.
Thank you. David, any views on that?
Yeah, so I see the world forking. I think Khalid said it earlier about the sovereign networks. So in sovereign networks, they want to retain that full control of all the assets end to end for the system, for their country, and where their folks may, their militaries, their defense teams may move beyond their borders. So in those senses, that vertically integrated network will stay in that regard. in other senses, as we said, Starlinks of the world will continue trying to stay vertically integrated. I predict, depending on where the geopolitical landscape shifts to, you'll either see more nation states and combinations of countries building these collaborative networks, in the EU especially with Iris Squared, or you're going to see, hopefully, my dream would be that they actually more like follow the cellular path, and we don't end up in a world where everything is siloed off, and we can have at least common standards, so you can roam across these networks. The nations and the continents and the unions can still control them, but it would be best for everybody if the bandwidth was, where possible, offered up for roaming across networks, and the peering agreements being created so that that becomes possible and the technologies being interoperable.
Thank you. Khalid, any final words on this question?
I think the new space era that we live in has allowed for a bubble, and many of my partners, when we converse on the subject, they think the bubble will burst at some point, and it will naturally calm down, and naturally, a few people are very well positioned politically, economically, and in many other aspects to be vertically integrated and global providers of satellite launch and services on the ground.
Thank you. Let's turn now to the question from the audience. So we have a first questions. Let me try. Yeah. We have a first question from Jivan Rao Subramanian regarding the role of GEO satellites in the future architecture. So I will read his question. So what services will require GEO in the future? And will there be a growth in the GEO market? Khalid, do you have any ideas on these questions?
Absolutely. I think if I understood the question correctly, I believe GEO is already super congested, and it will continue to serve both worlds: sovereignty for nations, maybe military networks, and in addition, some commercial services. But the LEO may reduce the market share for those commercially provided services due to the high cost of the megahertz. But they will always exist, those GEO assets.
Thank you. David, Per, and Ofer, any additional insights on this question?
Yeah, I think I agree with what you said, Khalid, and what you said, David, earlier with the sovereign solution. I think the beauty of GEO is that you are out there, you see a third part of the Earth. As a user, you can have full control end to end of your signal, and you can land it within your country. When you do LEO, most of the communication is terrestrially before ISL, then at least whenever it becomes fully deployed. So the signal will go more through vulnerable terrestrial networks. I think that is very important. That at least something we use a lot to sell, in addition to what we said, mobility, performance, and resiliency. But part of resiliency is sovereign solution. Yeah.
Thank you. Ofer,
I don't think GEO is going away. GEO will remain, and GEO will continue to populate the GEO arc and be there. And there are certain things that you can do with GEO that are better than LEO. LEO will become, let's say, the dominant over time, and LEO is suitable for low latency applications that GEO cannot support. But GEO is not going away, and GEO is here to stay.
Thank you. David?
Yeah, so I think the GEO market, what we're going to see is a reinvention of its business. So I don't think it should be put side by side with LEO as being the same service. That's not a winning formula for it per se. I think it offering different services, being both in space hubs and processing, and the kind of the idea of the servers in space that are coming in the future, so you're not actually having to land traffic to process data in the cloud, is one part of it. Two, my life before Chimera was about multicast content distribution networks. I think GEO is far superior for this capability than tying up the LEO networks with common packets of information being sent to many, many endpoints, far more efficiently done over GEO. And then the sovereign stuff we talked about before. I think all these things are going to redefine what becomes the future GEO use cases that lead that market to success.
Thank you. We have another interesting question as well from Sohail Khan regarding the role of hybrid networks. So what are the challenges when it comes to have roaming between terrestrial network and non-terrestrial networks? And how are these challenges overcome in current deployments, especially when LEO and GEOs are both used? David, do you want to, do you have any insight on this one?
All about managing what links have what latencies and dynamically monitoring the links. And then if you're trying to combine links, you can't combine very disparate, about 200 millisecond latencies, and then you have destructive combining. So if that's okay, the next step is application layer. If the applications require session continuity, then you have to put a solution in that provides that session continuity. Otherwise, you're going to have drop sessions. Things like Teams and Zoom have it built in, so you don't need that. So just like when you switch from your mobile to your home Wi-Fi, it can do that if the applications are resilient. But if the applications are not resilient, then you need common sessions.
Thank you. Ofer, do you have anything to add on this one?
Yes, the switching today is so fast that in many cases it's seamless to the user. As David said, you can have solutions that switch between GEO, LEO, and terrestrial within milliseconds. It's working today, so I think that we can put a V on this issue. It's working.
Thank you. I don't know, Per or Khalid, if you want to add anything on this question or not? No, specifically. All right.
Just to add one thing, if you allow me. Seamlessness is definitely the ultimate design when launching connectivity. And with inter-satellite links and the right distribution of POPs on the ground, I think that will, with what my colleagues mentioned about switching, will provide a seamless service.
Thank you. We have another question as well from Foggio Perez regarding D2D, and maybe Khalid, you can start with this one. The question is that 80% of the mobile traffic today occurs in indoor setting. To what extent will D2D be integrated into indoor network architectures?
So D2D will utilize the what formerly known as narrowband frequencies, and including terrestrial frequencies, which should penetrate buildings and will provide basically connectivity elsewhere. But combining this with Wi-Fi based calls and services, both will play together nicely in providing the experience.
Thank you. I am not the other panelists, please let me know if you have anything to add on this question. If you want to comment on that. No. Okay. All right. Let's move on to the next question. So we have an interesting question as well from Kartik Natarajan. We have discussed a lot about GEO and LEO, but we haven't spoken about MEO. What are your views on the MEO, and where do you think it can integrate in a global system architecture? Maybe we can start with you, Per, on this one.
Sure. And it goes back to what I said initially. I mean, it's the kind of the customer need that drives the need, and every orbit have some different advantages for sure. It depends on which altitude you have. I mean, MEO, there is a range here, and of course, if you come closer to the GEO, you will not have a latency benefit. So it's a kind of in the middle there. I think what SS have done is really great. I mean, trunk lines, a lot of capacity. They have been successful in that. I know there is a upcoming project in I think in Norway of kind of HEOP solution where you have, but then the apogee is extremely high. It's higher than GEO. So you have 12 hours. I don't know. I mean, no. So that's my comment. Again, it's the customer that drives the need really, and at least we focus on what we do here with GEO. So maybe the others have more good things to say.
Does anyone want to add anything on this question? Looking at your videos,
I like MEO too. So as long as I like all networks and all things for different reasons, and MEO has its benefits also. So yeah, I'm happy to see more network, more orbit diversity. I'd also like to see HEOs someday also incorporated into the mix. So I see benefits in all orbits.
I think the SES MEO constellation right now is a greater constellation. We are working over it. It has its own advantages, meaning once you go 8,000 kilometers into space, you of course see much larger area of the world. You need a very small number of gateways to control the constellation. SES implemented a very interesting antenna that can support thousands of links on every satellite. And for certain applications, let's say, for example, large ships that are looking for connectivity in the sea, this is a great solution.
Right. Thank you. So we only have time, I think, for one last question, and I have one on the future of mobility markets. So if you had to bet on one major disruptor for the next decade, so whether it could be a technical disruptor, a regulatory disruptor, or commercial disruptor, anything that would unlock a new era of growth for the sector, what would it be? So maybe we can start with you, Ofer. This one.
I will not count on the regulator to be the disruptor in the market. I think that more of the same, meaning the abundance of LEO constellations and the cost effectiveness of the solution being faster, cheaper, will be the dominant force that will introduce satellite into the mainstream of communications.
Thank you. David, you want to go next on this one?
Yeah, I think we just heard it. It's cost is the thing. So standards that I was told are non-negotiable requirements for a user terminal suddenly disappear when the cost drops by 90%. So there's a lot of compromise willing to be made when cost moves that dramatically.
All right, thank you. Per?
Yeah, no, I agree on that. And what more, maybe more processing moving. I mean, we have moved some intelligence up in space, and that will continue to rely less on the kind of gateway infrastructure. I think that so you can connect directly from one, small device directly to another one, like we do then with Ovzon 3, I think. And to connect then with ISL, even in GEO, that's at least what we work with. Yeah.
Thank you. And Khalid?
I concur with my colleagues. I think the products, without any unforeseen challenges globally, will drop price quite massively and will allow for connectivity to be just a necessity everywhere and at any time.
Perfect. Well, I think this brings us to the end of today's discussion. So any question that we didn't have time to answer today during the live program will be addressed in writing and posted alongside the video on the GSOA website, provided, of course, that they are relevant to today's topic. So you can watch the recording of this webinar as well as previous ones on our YouTube channel and on gsoasatellite.com. Of course, join us again for our next event. Please visit the GSOA website for details on upcoming webinars or to watch any of the past sessions free and on demand. I'd like to thank a lot, address a big thank you to today's panelists for sharing their valuable insights, and of course to our audience for your thoughtful questions and your active participations. So thanks a lot, everyone. Enjoy the rest of your day, wherever you are in the world, whether it's the morning or the evening. Have a great day and see you soon.